Eighth graders, this is lesson 10, session 2, which starts on page 231. And today we are solving linear equations with one variable, but this time the variable is on both sides. Yesterday for session 1, the variable was on one side. Today it's on both. So our first question here, the triad problem, says Emma is 1/4 as old as her father. In 20 years, Emma will be half as old as her father. This equation, right here, represents this situation where x is Emma's father's current age. So x is how old this guy is. Okay, how old is Emma's father now and how old is Emma now? Okay, so let's math this out. So Emma is 1/4 of her father's age. And in 20 years, she will be 1/2 of her father's age. So we have to solve for x. And remember, your goal here is to get the variable all by itself. You need to get the x by itself. But first, we have to get the x on just one side. You can't have it by itself on both sides. So we're going to have to do one thing at a time here. The first thing we're going to do is we're going to take this 1/2 and we're going to distribute it to the terms inside of the parentheses. And you know that I like to have a big line down the middle to remember which half of the equation I'm working on. Because remember, the rule here is you can do whatever you want to each half of the equation as long as it's the same thing on both sides. Do whatever you want to, you can do whatever you want to it as long as you do the same thing to both sides. So I'm not doing anything to this side at all. All I'm doing right now is I'm distributing what's already on the right side. So 1/2 times x is 1/2 x. 1/2 times 20 is 10, because what's 1/2 of 20? It's 10. Okay? Now I need to either put the 1/2 x over there or put the 1/4 x over there. And I think what I want to do is, I think I want to move the 1/4 x. You can choose differently if you want to. And the way I do this is I have a positive 1/4 x. So I'm going to put the opposite there, a negative 1/4 x, because those will cancel out. And now that 1/4 x is gone. But I have to do the same thing over here, negative 1/4 x. So what's 1/2 minus 1/4? 1/2 minus 1/4 equals, I need to have the same denominator here. So I'm going to multiply by 2, multiply by 2. That'll give me 2/4 minus 1/4. Which 2 minus 1 is 1. 4, that doesn't change. What am I saying? That doesn't change. So it's 1/4. Okay, so back over here, I've got this 20, didn't change. And I've got 1/2 minus 1/4, which is 1/4, plus 10. Okay, still on the path to isolating that x, getting it by itself. So the next thing that I want to do is get rid of the constant that's nearby. How do I get rid of a plus 10 or a positive 10? I put a negative 10. I'm going to put a negative 10 on this side. So now I've got that canceled out. So I've got 1/4 x, and 20 minus 10 is 10. Okay, still on the road to isolating that variable. Make that a little bit longer. I need to get rid of the coefficient that's with the x. And if you recall, the coefficient, because it's touching the x, that means they are multiplying. It's 1/4 times x. So in order to get rid of the coefficient, I need to do the opposite. I need to divide both sides. Oops, I'm going to put the division symbol. Or you could do it this way. You could put you can write division like a fraction number. So I'll divide by 1/4. that's going to cancel out to 1. Because remember, if I do over here 1/4 divided by 1/4, if I do keep, change, flip, it's now 1 times 4 is 4. 4 times 1 is 4. If the numerator and denominator are the same, it's 1. So this is now 1x by itself. Okay. And I have to also divide 10 by 1/4. So I'll do that. I'm going to do that in purple over here. 10 divided by 1/4. If it helps you to turn the 10 into a fraction, remember you just put a 1 under it. Now it's a fraction. So keep, change, flip, and that's just 10 times 4 is 40. 1 times 1 is 1, but you don't really need that, do you? So x is 40. Emma's father is 40 years old. So that's Emma's, oops, gotta capitalize Emma for goodness sakes. Emma's father. And she's 1/4 of his age. What's 1/4 of 40? Emma is 10. Okay. Now let's check out our modelets over here. So let's see, what's the difference between these two? It's both basically the same thing that we did, but let's see what the difference is. It says for this one, you can multiply both sides of the equation by 4 first. Then use the distributive property again and combine like terms. So if you wanted to first and foremost get rid of this 1/4, then you would multiply the whole thing by 4. You could do that if you want to. I don't super know why you would, but you could. It's nothing wrong with it. We did this method. We distributed the 1/2 as our first step, because I thought that made the most sense. Okay, let's see what our book wants us to do to analyze this now. Explain each part of the equation 1/4 x plus 20 equals 1/2 of x plus 20 represents in this situation. So we have to we have to explain each part. I'm going to do it by pointing. So this is Emma is 1/4 her father's age. And then we added 20 years. I'll put it like this. In 20 years, Emma, oopsie, I don't capitalize her name, that's shameful. It's her name. Gotta capitalize names. In 20 years, Emma, I did it again, will be half her father's age. There you go. Number 2 says, look at both modelets. Why does it make sense to multiply both sides by 4 first in the first modelet? Well, why did that? Okay, why does it make sense to use the distributive property first in the second modelet? Well, in the first modelet, they wanted to get rid of the 1/4 first. In the second modelet, they just wanted to distribute first, I guess. But how could we word that in a more proper way? The first one's pretty easy. The least common multiple of the 4 and 2, and those are the denominators for the fractions, remember, the 1/4 and the 1/2. So the least common multiple for those is 4, so multiplying by 4 gets rid of the fractions. There we go. So maybe you hate adding and subtracting fractions, you want to get rid of them that way. Now for the other one, for the second modelet, distributing the 1/2 first would also get rid of the parentheses. That's not how you spell parentheses. There's an E there. There we go. So those are your basic choices. Number 3, look at both modulets. Finish the solution for each method. Does it matter which solution you use? Explain. Well, I hope not. You can't have a different value for x if you're using the same equation. All right, let's finish these. We'll just finish them on this page so we don't have to rewrite them. Okay, so we're just going to go straight down here. And I'm going to do my line because it just makes me feel fancy. So I've got to get the x by itself, which means I need to get rid of the positive 40. Oops, why did I write 44? Goodness sakes. Okay, get rid of the positive 40. That's gone. X is all alone, all lonesome. Move it up a little bit. But I have to do the same thing over here. 80 minus 40 is 40. Ta-da! And then we already did this one, didn't we? We did divided by 1/4, which is 1x. 1/4 divided by 1/4 is 1x. And 10 divided by 1/4 is still 40. Okay. So, where's my text tool? There we go. They're both 40. They'll give the same solution because, I need to zoom out a little bit. Zooming out erased my answer. So they're both 40. It doesn't matter whether you eliminate the fractions first or use the distributive property first. Distributive property on the 1/2 first, because both methods keep the equation balanced. There we go. And remember, we just have to keep that equation balanced. You do the same thing to both sides. You want to add 1,000,000 to both sides? Go ahead. It's still going to give you the same answer. You're just going to have a lot more zeros to deal with. What's Emma's age now? She is 10. He is 40. And now we have to explain a very important step. We always need to explain our thinking. And Emma's father is 40 because x equals 40. Oop, 4. And Emma is 1/4 of that, which is 10. There you go. And then number 5 is for you to do. It says, think about all the models and strategies you have discussed today. Describe how one of them helped you better understand solving linear equations in one variable with the variable on both sides of the equation. So basically, of all the things we did so far, what made the most sense to you? Pause, answer that, and we'll practice together. Okay, you paused, we're back, and we're going to number 6, 7, and 8 as practice together. Ooh, rainbow. Alright, what is the solution for this equation? Show your work. And I don't want to rewrite it, so I'm just going to zoom right in and get out my drawing tool and start. I like to start by drawing that big line there to show my 2 halves of the equation, and now I can do whatever I want. Okay, so they showed us 2 different methods. They showed us multiplying by multiplying the whole thing by the least common multiple of the denominators. So should we do that? We could. Okay, we'll do that. You could also just distribute the 1/3 to what's in there. But I think I'm going to try this other method where we multiply by the least common multiple. So the least common multiple of 2 and 3 is 6. That's the smallest number that will go into both of those numbers. So I have to multiply this whole thing and this whole thing by 6. All right, so 2 times 6 is 2 times 6. Well, I can't remember 2 times 6. 12x. 2 times 4 is, oh wait, that's plus addition. 2 times 4 is 24. And 6 times 3 is 18. 18 divided by 2 is 9x. And then over here, we just have to do the 6 times the 1/3, which is 6 times 1/3 is 6/3. 6 divided by 3 is 2. And that will give me 2 times x plus 5. I can do that in the next step. I don't want to go ahead too many steps. So I'm going to keep this side the same because I need to distribute that 2. Okay, 2 times x is 2x. 2 times 5 is 10. Alright. I should have made this a rainbow. Remember next time do rainbow order. Wait, checking my work. When I did, let's see, 6 times 2. Okay, yes, it's still good. So now, let's see, what can I do? I can move this 2x over. I can do that. I can move this plus 24 over. I can do that. The thing that I choose to do next is I'm going to combine like terms because I see on this side I've got 12x's here and negative 9x's here. So what's 12x's minus 9x's? Well, that is going to be 3x's. And then I'm going to keep my plus 24. So I just combine, all I did was combine these two terms right here. It's called combining like terms. And then I haven't done anything over here this time. Okay, now the thing that I want to do is get my x's on the same side. And I'm going to get these positive 2x's out of there by putting a negative 2x there. That gets rid of them. But that means I have to put a negative 2x on this side. 3x minus 2x, ta-da! I have 1x left. How convenient. But I still have the plus 24. It's not alone yet. Equals 10. All that's left on that side is the 10. So now all that's left with my x is a positive 24. I'm going to get rid of it with a negative, 24. That's gone. X is all alone forever and ever. 10 minus 24. Well, the difference between 10 and 24 is 14, and the bigger number is negative, so the answer will be negative. So x is, let's circle that. X is negative 14. X is negative 14. Let's see what's coming up next. Okay, number 7. Mr. Gordon buys packages of clay. Some of the packages are on sale. 5 packages that are on sale cost the same as 3 packages that are not. So they've put this equation right here. 5 equals price times, or price times. 5 times P minus 250 equals 3P. Okay, P is the price of the package of clay that is not on sale. What is the price of the package of clay that is not on sale? Okay. Okay, so basically what they've done here is he's bought 5 packages on sale, and they are each apparently discounted by 250. So the price minus 250 times the 5 packages he bought, and then on the other side it's just 3 packages times the price. So we need some more space to work on this. I'm going to cheat and just zoom in really big. So neater. You can't zoom in. You'll just have to make a mess of your paper. Okay, 5 times, do I even have enough room? I'm going to give myself a little more room. There you go. 5 times the price minus $2.50. I don't need that 0 there. I'm not going to put it. That's a superfluous 0. Equals 3 packages at the regular price. Got my line to isolate my P. Okay, I'm just going to distribute the 5 into the P and the negative 2.5. 5 times P is just 5P. And then 5 times 2.5, I guess I should show my work for that. I'm going to show my work for that over here. 2.5 times 5. 5 times 5 is 25. Carry the 2. 5 times 2 is 10. Plus 2 is 12. So that's $12.50 was his savings. That's a pretty good savings, right? Saved $12.50 on that sale. And then the price, the regular price for the 3. Okay, so I've distributed that 5 out. Now I want to get the P by itself, but I've already got a P by itself over there. So I don't really want to move the 12 and then the 3. I could move the 12 over there and then the 3 over there, but I don't, or the 3P over there, but I don't want to. So I think what I will do is I'm just going to take that positive 5P and put a negative 5P so that it cancels out. That means I have a negative 5P on this side. 3 positives and 2 negatives. Okay, well the difference between 5 and 3 is 2. And the bigger number is negative, so my answer is negative. And then my negative 12.5 remains the same. However, if both sides are negative, I'm just going to make both of them positive. So you can just think of that as I multiplied the whole thing by negative 1. Because I can do that. Because I can do whatever I want as long as I do the same thing to both sides. Let's use green. Okay, so I need to get that 2 off of that P. I need to get rid of that coefficient. So I'm going to divide by 2. 2 divided by 2 is 1. So I have 1 P remaining. 12.5 divided by 2. I guess I can show my work for that. 12.5 divided by 2. So 2 goes into 12 6 times. That does make 12. However, I still have a 0.5, and I cannot, well, I guess I could. Yeah, 2 goes into 5 2 times, but that makes 4. So my remainder there is 1, but I can't have a remainder. I have a decimal, so I'm just going to put a 0 there, because once you got a decimal, you can put as many zeros as you want. 2 goes into 10 5 times. That does make 10. I'm done so there. So 6.25 is the price per clay. Is it always that expensive now? I used to get this stuff when I was a kid all the time. I don't remember being $6.25 a brick. I hope it's not that much. It probably is. It's not the 90s anymore, is it? Okay. Number 8. I guess I should zoom right back in, huh? Solve the equation. Show your work. The rainbow is nice. Okay, we're doing another rainbow one. Let me get this out of the way. Get out of here. You're confusing me with all your existing. Okay, number 8. Solve this equation. Show your work. Simple directions there. Let's just do black line. Okay. I'm just going to distribute. I find it the easiest to do 0.4 times 20, 0.4 times negative 10m. Okay, so 0.4 times 20 is 8. 0.4 times 20 is 8. 0.4 times negative 10 is negative 4m. And I only distributed, so I didn't actually do anything fancy, so this side hasn't changed yet. Okay, now what's going on this side? Since there are too many terms over here, there's a 2.5 and a negative 12. Let me combine those. 2. I'm not going to mess with this side this time because I want to combine these terms. So 2.5 minus 12 is, oh wait, it's 12.5. You almost let me mess it up. Why aren't you yelling at me through the computer screen loud enough? Whoops. Okay, 2.5 minus 12.5. That one's a lot easier to do, actually. So that's negative 10. Negative 10 minus 2m. Wrong color. There we go. Now it's the right color. Negative 10 minus 2m. Okay, we did our distributing, then we did our combining like terms. Now we're ready to keep this equation balanced by doing whatever we want to both sides. So what I want to do is, I think that I would like to move the negative 4m over to the other side. So if I have a negative 4m, I'm going to get rid of it on this side with a positive 4m. Now it's gone. That means I need a positive 4m on this side. So this 8 is now all alone. I've got a negative 10 on this side, and I've got a negative 2 and a positive 4. A negative 2 and let's see, negative 2 plus 4 is going to give me positive 2m. Okay, we're getting close. Blue step. Okay, I've got my m on this side, so I need to get rid of this negative 10 by putting a positive 10. Which means I need to put a positive 10 on this side. 8 plus 10. I can do that in my head. That's 18. 18 equals 2m. And my last step, we're getting a full rainbow out of this one, except for yellow, obviously, but you wouldn't want me to write in yellow. I need to get rid of the coefficient of 2, so I'm going to divide by 2. M equals 9. There we go. Okay, just remember, do it one step at a time. There's not one right way to do it. Take your time with it and check your work between each problem to make sure you got it. And you can also check each step with the calculator after you've tried it on your own. Check with the calculator. So good luck.